Hello, my name is Daniel Houston, and this is my public lecture review of Dr. Sarah Seeger from MIT's public lecture on exoplanets and the James Webb Space Telescope for Physics 2212. So, to summarize this lecture, this would look at two main aspects of exoplanets, and the first being the discovery of possibly another Earth that we could live on, or there was also the idea of searching for other signs of life by using atmospheric biosignature gases, and this would look at specific gases such as like nitrogen or ammonia to see if life already exists there, and then going back to the first thing, whether we could live there. And so first, looking at the James Webb Telescope, this is probably one of the largest telescopes ever made, being the size of a 3-story building, and this is the most powerful telescope to exist, and this uses infrared radiation to see, and which is lets it able to see through dust clouds, which is very significant when looking at space telescopes. And then this telescope actually has these giant gold-coated reflectors used to make more advanced images. And this telescope is used to find exoplanets by using a transit method, which looks at the brightness of stars and notices the dips in the brightness. So specifically, the amount of the brightness that these dips would occur would allow the telescope to determine the size of these exoplanets, and then would also use the lengths of the dips to determine the different orbits. So like either the distance from the star that it's orbiting, or just the amount of time that it takes to orbit. So it could be anywhere from a couple of days to a few years compared to Earth. And then, yes, all of these exoplanets come into a variety of sizes, ranging from like the gas giants, such as like Jupiter, or it could be about the size of Earth or Mars. And these are like small rocky planets. And some of these are hot enough to be able to boil metal, or locked into deep freeze in space. So it's really a range. It's not really like one and done. Like they're all exactly the same. And then these can orbit their stars tightly, like I said before, that can last years or just a few days. And they can also orbit 2 suns at once, so similar to some science fictions like in Star Wars where they had 2 suns. So I thought that was pretty interesting to see how you could have more than one sun, so maybe you could have 2 shadows. And so some of these exoplanets are sunless rogues, and they just wander through the galaxy, and they just don't even have a sun, which is also like really weird to think about, because then it wouldn't be able to have any life. And so one of the best examples seen of a solar system similar to ours is the TRAPPIST-1, which is about 40 light years away, which is not too bad. And these have a bunch of Earth-sized planets that orbit a small red star, and that's actually a really good example of a solar system nearby us. And one of the things that is very similar to our studies that we do in physics too is kind of looking at and this would be looking at the correlation between the magnetic fields of planets and the ability for a planet to hold life. And so I thought that was very interesting, that I did outside of this lecture. And then thank you for watching my public lecture review. I hope you all have a good day.